All right, greetings, Saintsmen. This is special right triangles. Um, the lesson here is actually going to involve. Let me actually go ahead and set up real quick. Where did it go? Draw. Here we go. Auto shapes. So we have to suffer through my poor drawings here. Leave this tool on here. So we're going to work with special right triangles. First one that we're going to deal with here, and getting back to that Pythagorean theorem that we had dealt with, right? Which was dictating that when we have the sum of the two legs squared, it's equal to the hypotenuse squared. These right here, A and B, are the legs, and then C here is the hypotenuse. Which is always going to be, right? This guy's going to be opposite the right angle. This guy's going to be C. And then here and here, these are my legs. All right? So this would be A, this would be B. So let's go ahead and start over here with these. What I'm going to have here is that if I have a particularly special right triangle, all right? Special, gentlemen. Saintsmen, these triangles are very special, just like you guys. Showing that if I have X here, if I had A and B squared, A squared and B squared, and if I were going to call this guy A, okay, let's just call this guy X. What it means is that this other side also has to be X. Moreover, what I have right here is an isosceles triangle. So the question is, what is the degree measure for each of these angles? Well, it has to be, oh goodness, this thing is going to like autocorrect every single thing that I write here. So let's go ahead and turn that off. 45 degrees. 45 degrees, right? Because it's an isosceles triangle. I have the two, and again, it's a right triangle. So remember, these acute angles have to be, through corollary, have to be complementary. So then, if it's an isosceles triangles, these are going to be base angles, this guy, and have to be congruent as these two legs. So what is this side right here going to be equal to? All right. So let's go ahead and do it. We'll have x squared plus x squared, a squared plus b squared, which is going to be equal to whatever that last side is squared. All right. So x squared plus x squared is 2x squared, isn't it? So I'm just going to do some algebra here. And then, of course, I just want to know what this guy is over here. So how do I get that question mark by itself? Well, let's go ahead and just take a square root of both sides. So I'm going to leave that step here and show that operation where I took the square root. All right. Now, on the right side, that question mark, the square root of the question mark, squared is just going to be the question mark. The square root of x squared is just going to be x. And then rad 2 is going to be stuck inside the radicand, and that's what this question mark is going to be equal to. All right. So this is going to be x rad 2. This is what is called an isosceles right triangle, which is a 45, 45, 90 triangle. So here's where less is more. If you pay attention to this lesson, you don't have to utilize this Pythagorean theorem. This is a shortcut. When we recognize that we have a 45, 45, 90 triangle, which happens when we have two congruent sides, right? Then this is going to be the hypotenuse is the legs, or the one of the legs, because they're the same, times rad 2. So let's actually try it out, okay? Let's get a little example here. Actually get this thing back in here and implement it, because you guys don't want to have to deal with my drawings. All right. Isosceles right triangle. We have 22, 22, and this is x. So the question is, what does this become? Well, remember, this side right here, that's the hypotenuse, is going to be equal to a leg, which are the same, times rad 2. So this is just going to be merely 22 rad 2. Okay. It's pretty straightforward, right? How about this? I have x, and I have x, and I have 10 rad 2. And this is all I'm given in my right triangle. Okay. Now, is it marked that they are congruent? Well, it is, because it's telling me that I have x and x, which is the same, which means that these guys have to be the same, right? So then all this is going to be is that in order to go from here to here, from the leg to the hypotenuse, I multiplied by rad 2. So to go the other way, I'm going to divide by rad 2. So this is just going to be 10 by itself, right? Where right up above, where I went from the leg to this hypotenuse, gave me 22 rad 2. I already was given the 10 rad 2, so on the side, the leg has to be 10. I hope you guys see that this is pretty straightforward from this regard, okay? So let's actually make it challenging right away, right now, all right? Here we go. What if I have rad 2 and rad 2, and then I have to solve for y? What does y equal? Well, remember, this, it's not that oops, oh my gosh, what did I do here? It's not that I added rad 2 on here, it's that I'm multiplying by rad 2 to go from the leg to the hypotenuse. All right, so what's rad 2 times rad 2? Well, that's rad 2 squared, right? That's just going to merely be 2. Rad 2 times rad 2. All right. Pretty straightforward. That's my 45, 45, 90. I'm going to give you guys one more example here. What if I had y, and 4? Ooh, this is a tough one. Now remember, to go to this side, if I multiplied by rad 2 now, I need to divide by rad 2. Okay? Not by 2, but by rad 2. So what I'm going to do here is that y is going to be equal to the hypotenuse divided by rad 2. Now, I cannot leave this radical in the denominator. Okay? So, I'm going to have to take this, my 4 rad 2. Okay? And I have to multiply by 1, because this is the multiplicative identity. Remember, a over a is equal to 1. Everything times 1, I could take 5 times 1, and it's equal to 5. I then can take 1,000 times 1, and it equals 1,000. So I'm not changing the value of this by multiplying this thing by 1. But what I do is I rationalize this denominator. So I do my numerator, so it's 4 times rad 2, which is 4 rad 2. But rad 2 times rad 2, it's going to rationalize this, and it's going to get rid of that radical. So rad 2 times rad 2 is rad 2 squared, which is just 2. It's the idea, like if I had a 2 and I was going to do times 2 divide by 2, it's still just 2. Or if I took 3 and I divided by 2 and multiplied by 2, it's still going to be 3. Or if I took 10 and I have to subtract by 2 and then add 2, it's still 10, right? If I do the same thing unto itself. So then now I just need to reduce this guy, right? And I'm going to be left with 2 rad 2. All right. New triangle for you guys. You guys ready? So, let's take an equilateral triangle. All right? This guy is an equilateral triangle by definition, meaning that every single angle is 60 degrees. All right. Take off this auto shapes thing for a sec. So, think about this. What if every single side here were equal to 2x? If this is 2x, then this is 2x, then this is 2x. And rather than saying this than just x, right? I could do the same thing. If one is x, then they're all x. So if one is 2x, then they're all 2x. Now I'm going to use 2x purposely, and you guys are going to see why in just a moment. I'm going to take this line right here. So we've been working recently in a equilateral triangle. This is unique in that this line right here is a median, an altitude, a perpendicular bisector, and an angle bisector. It's all those lines in one. Okay? So what I've created here, if I've created an angle bisector, this has got to be 30 degrees. It has to be, right? Because now my right triangle, and then these guys have to be complementary. So the 60 and the 30. Moreover, right, these are going to each be 30, and this is going to be an angle bisector, right? And I've got my right angle right here. So the question is, what is this value and what is this value? Well, remember we talked about, if this has been halved right here, because this is a median, all in one, if this is x, to go from here to here, I have half it, and this is going to be half of 2x, which is just x. Okay? I think that one's actually pretty straightforward. The question, though, is what is this line right here that's y? Well, let's just use the Pythagorean theorem, right? Why don't we have y squared plus x squared, right? A squared and b squared, which is going to be equal to that hypotenuse, which is 2x squared. But it's the side times itself, right? It's 2x times 2x. So I have y squared plus x squared is really equal to 2x times 2x is going to be 4x squared. I want to actually work that out. Now, let's move these because we're going to solve for y. I have these other values that are x. I can actually move these over here to the left side. So I'm going to cancel this out. So I have y squared. And this is, I'm doing a proof for you right now so I can give you guys the relationship. So y squared is equal to 3x squared. Now I could get y by itself. I'm going to just take one more thing so you guys can see me operate here. On a blank thing. To get y by itself, I have to take a square root of both sides. The square root of y squared is just y. I have the radicand. The square root of 3 is the 3 stuck inside, but the square root of x squared is just x. So y is equal to x rad 3. That is this value. So that gives me all of the sides of what is called a 30, 60, 90 triangle. And that's our second special triangle today. I know, 45, 45, 90 was one special triangle. There's one other. And he's going to be pretty straightforward. We're going to identify 3 things here. Okay? And it's this. When I have this, oops, oh my gosh. Look how bad my triangles are, guys. I told you, I'm not a talented artist. But I'm going to make the machine work for me here. All right. Here's my triangle. It's a 30, 60, 90. How do I know which is which? Well, the small angle has to be 30, right? The big angle has to be 60. And of course, this is going to be my short leg that's opposite the shortest side, right? So this is the short leg, or SL. This is the long leg, right? That's opposite this. And now the biggest side always is the hypotenuse anyway. Remember, this guy would be 2x. Short leg is half. The long leg is the short leg times rad 3. Here is my 30, 60, 90. All right? So let's do some examples. Here we go. Oh, goodness gracious. That's such a bad triangle, the software didn't even recognize it. So sad. All I'm given here is that I have a right triangle with a hypotenuse of 40 and one of the acute angles is 60. Well, this has to be 30, 60, 90 since this is 90 and the other one's 60. The third angle has to be 30 because the interior angle sum has to be 180. So, right? So 90 plus 60, and then this would have to be, 30 right here in this tiny angle to get me up to the 180. X is going to be half the hypotenuse, so it's going to be 20. And then Y is going to be the short leg times rad 3. So 20 rad 3. That's my answer. All right. So I'm going to give you guys 4 examples here. All right, and then we'll do some in class once we get here. Once we get together. Anything? Oh no, it's still on AutoShapes, just hating my poor drawings. Okay. Let's draw our 4 right triangles. Let's go and turn this AutoShapes off for a sec so it's not so crazy. Here's what we got. This is 30 degrees up here. That's this tiny acute angle. This is 5 rad 3. On my next triangle over here, this leg is 20. And then these acute angles are 45 degrees each. And this one right here, I've got these 2 congruent sides, and then this side, which is 6. And then I've got this long leg, which is 6. And then this acute angle, which is 60 degrees. Okay, so we write that 60. Okay. It wants us to solve for x here, x here, x here, and x right here. All right, those are my 4 x's. So let's solve for x. Well, this right here is a 30, 60, 90. They gave me my long leg, okay? To go to long leg to short leg, I have to divide by rad 3, right? Because that's the way this guy goes. This is going to be divide by rad 3, and this is going to be times 2. If I were going to go in the other way around, right? This would be divide by rad 2, and this would be, goodness, I just put divide by 3. This is divide by rad 3. And this would be times rad 3. All right? So you're going to want to take this note right here. Let's go clean this whole thing up. And let's just operate. Down here. Divide by rad 3. All right? Which is going to be 5 rad 3 divided by rad 3. These guys factor out. This is a 5. So this is a 5 right here. And then you go right here, I just multiply by 2. So 5 times 2 is 10. Cool. To go from here to here, I have to multiply by rad 2. So this one's pretty straightforward. This is just going to be a 20 rad 2. Awesome. To go this way, right, I have to divide by rad 2. So, sidebar, I got x, which is going to be equal to 6 over rad 2 divided by rad 2. But we can't leave it like this, right? Doesn't work. That's not correct. You'll get deducted. Or points deducted. So I'm going to multiply by rad 2 over rad 2. I'm going to multiply by 1, right? Which is going to be equal to 6 rad 2 over rad 2 divided by rad 2 times rad 2 is 2. And I factor these guys to be a 3. So x is equal to 3 rad 2. And last but not least, this is the toughest one because I got to get to the short leg first. I always have to go through the short leg. To go through short leg. To go from long leg and, oops, hypotenuse. Either way you go, okay? By the way, I'm looking for this little note that you have right here to see if you guys actually have completed your notes. And if you didn't just turn the volume off or put it at ×2 speed and just moved along quickly. So to go through here, we're going to go 6. I'm going to divide by rad 3, which is going to be rad 3 multiplied by rad 3 over rad 3, which will give me 6 rad 3 over 3, right? Rad 3 times rad 3 is 3. So this will be really 2 rad 3. So this is this guy right here. 2 rad 3. And then you go up here and just multiply times 2. So x is equal to 2 times 2 rad 3, which is 4 rad 3. All right. If you have questions, come see me during office hours. Good luck.